once let my daughter listen to one of my tapes or one of my videos, and she said, yeah, you seemed really enthusiastic, and I have no idea what you were talking about. So today's talk is entitled Enterprise Strength Mobile JavaScript, subtitle, Unit Testing and Debugging in the Real World. This talk is based upon my 14 months or so of developing the KBB.com mobile version, which we just released back in June. Towards the end of June we released it, and it's up there and it's live now. So if you hit it with your iPhone or your Android phone, you'll see lots of nice little features. It was built with JavaScript, jQuery mobile, backbone, and underscore, and just a lot of sweat, and mainly because certain people kept changing their minds. But we won't say anything about the product people. As Atan mentioned, I will be speaking at JavaScript Saturday. If you are in the web world in any way, shape, or form, I would highly recommend this. Not just because I'm going to be speaking, but because it's a one-day chance for you to get concentrated JavaScript information. Usually JavaScript is a side show event at any conference. It's sort of just, there's a couple of sessions on some JavaScript, but if you sit there and you work in the real world today, you know that there's a lot of heavy JavaScript coding going on, and for some reason there's not a lot of heavy JavaScript conferences out there. Yes, sir?
That said, I heard that JavaScript is the most popular language in the world. Every device uses it, not just websites, everything uses it.
We'll get into that. The statement was that JavaScript, I'm repeating this because I record these things. JavaScript was the most popular language in the world, and I actually have a lot of things to say about that, and we'll get into that as our talk progresses. So the agenda for tonight, we're going to talk about the rise of JavaScript. We're going to get into best practices with JavaScript. We're going to talk about unit testing and debugging. So starting right off with the rise of JavaScript. There's 4 little topics here. Why is JavaScript so important? Why JavaScript sucks, and that has to be attended to. Why is good JavaScript so hard to do? And we're going to get into a little bit of historical context, which I always feel is important, because anytime you kind of get into a new language, a new paradigm, a new metaphor, it's important to understand the context at which this language was written. Because if you looked at COBOL programming today, you would go, well, what were people thinking? But then if you actually took into the fact that the historical context of the machines that they were dealing with, that they were batch served machines, and they weren't like the machines that we use today, it helps shed a little bit of light of what the developers at that time were thinking and why they developed this particular language, COBOL, Fortran, and why they were done that certain way. So historical context is always important. And going from one important thing to the other, why is JavaScript so important? So to answer that question, we have to take a little trip in our Wayback Machine. Got to go back 10 whole years. Doesn't sound like a lot of time, but this was one of the most popular websites at the time, 10 years ago. Quite stunning, isn't it? We look at it today, and at its time it was state-of-the-art. Google was still just, they were coming up, and they're up and coming, and they were still, nipping at Yahoo's heels, but they were the big boys on the block as far as if you were looking for something on the internet. This is the place where you started. This was a lot of people's homepage on the internet, where they started, whatever their web surfing session was. And then in the intervening 10 years, these things happened, and more. So you had companies like, Google Maps came out, Facebook was created, Gmail, Twitter, LinkedIn, Netflix, and by Netflix, very specifically, I mean the streaming part of Netflix, not the, the DVD service, which could have been done, using by mail. But these kind of apps revealed a whole new paradigm, especially Gmail. Because at the time when it came out, it was sort of like the forerunner of all the things that were going to come, where you had this single page app that could do so many things that you used to think only could be done as an application. Because at the time, so many apps were in that vein of, you get an HTML page, you fill out some forms, you hit a submit button, it goes back to the server, and that was what people thought the web was for. Great for looking at photos, for reading documents, but not too great for interactivity. and especially Google Maps. Google Maps, when it first came out, I spent days trying to pick that thing apart and understand how it was working. And it was doing things that I thought were so freaking clever because none of it was hidden. The web is an open standard. There's no tricks that you can put in it, but there's new ways that you can think to use the pieces that you have. And so it did a lot of interesting things. But what's important about all of these applications is none of them could be done using the old paradigm of, you know, deliver a page, hit submit, get some data back. They had to be done very heavy client side. They had to use JavaScript. So that brings us to the question, which comes to a lot of programmers' mind, especially people that aren't too fond of JavaScript, is why JavaScript sucks. And it's an absolutely valid question, because even somebody like me, I have a fondness for JavaScript, there's some crazy stuff in there where you go, okay, what the hell is going on? Why did they even stick this in there if it could only get me into trouble? So to answer that question, we're going to look at three separate things. We're going to talk about the DOM, we're going to talk about the internet's long tail, and we're going to answer the limerick, Java is to JavaScript. The first thing is, the main thing that people hate about JavaScript isn't even JavaScript. And most people don't recognize the distinction that the browser and JavaScript are two separate things. So the DOM, the document model of the browser, is a very complicated piece of dynamic data. And I emphasize the word dynamic. What people don't realize about the DOM is even when you access something, like you say, you know, element.something.something, it's updating that whole DOM as you're doing this. And this makes the DOM really, really slow to work with. And so this thing, a lot of people get it confused. They say, well, it's so slow, it does this. They'll say JavaScript is really, really slow, and they'll give some example, and it'll always be some example where they're moving divs around on the screen, or they're accessing something, and they're doing something with the DOM, but not realizing that it's not actually part of JavaScript, because most people, and only the masochists amongst us, have never read the actual W3 spec. 3C spec. But just if you take one thing out of this, just remember that the DOM is not JavaScript. It's a whole separate entity. It's regulated in a different way, and it has a really complicated task, and that's part of the reason why it's so slow. The other thing is that the internet has a really long tail, meaning that even when you recognize something is wrong and you want to change it, because it is managed by a standards body, in the case of JavaScript, it's ECMA, which is the European Computer Manufacturers Association. Although officially now, ECMA is not an abbreviation, it's their name, which is why it's E-c-M-A. And you know, anytime you have a standard, you have a bunch of people, usually powerful corporations. Powerful corporations who have interests that are competing with each other. So if Apple proposes some change to JavaScript, and odds are they've already written the code, so Microsoft, of course, is going to go, no, because we don't have the code. And so they already know that if Apple proposes it, they're probably going to have an update to, you know, Safari in a very short amount of time from the point everybody says yes, and they're going to make that change, and they're going to say, hey, we've got this feature, Microsoft doesn't. And these sort of competing interests go on a lot in the world of the web. With the browsers, with the things that are supported in the browser, I mean, people think HTML5 is new. It's not. It's just that it's taken this long for, you know, the browser manufacturers to start implementing it, and it hasn't even been ratified yet. And the latest estimate I read that it would be fully ratified is 2020. And so if you're hoping for things in HTML6, you might want to start working on some grandkids that can code. But it's also a really realistic thing, is that there are millions upon millions, if not billions, of web pages out there running software, and ECMA, of course, is afraid of breaking people's code. So if you've got something, it's out there working, You've worked around the little idiosyncrasies in JavaScript, the things that are probably written badly. You've got your stuff working, and then somebody comes along and says, hey, we're going to fix all the browsers. You're going to need to take those fixes out of your code so your code doesn't break now. You, of course, are going to go, I'm not going to spend God knows how much money updating everything. Why should I have to do that? And so this is one of the reasons why everything in the internet, even though the internet itself moves fastly, changes to the internet move very, very slowly. So there were things that they knew were broken in JavaScript, but they could not fix because it would break other people's code. The final thing is that, you know, Java is to JavaScript as car is to carpet, meaning they have nothing in common with each other. JavaScript was written in 10 days by a guy named Brendan Eich at the time working for a company called Netscape. For you kids, it used to be a company that competed with Microsoft. Let that be a lesson to you. And at the time it was called Livescape. Now you got to remember, at that time Netscape was in a vicious, you know, dog-eat-dog kind of battle for browser supremacy over this new thing called the internet. And they partnered up with Sun. You know, they figured that the two of them should be adequate to do battle with Microsoft. Oh, for those of you that don't know, Sun used to be another company that did battle with Microsoft, and they don't exist anymore either. And they needed to get this thing, they knew that you needed something in the browser to give you a little bit more client-side control. And so they hired Brendan, who's a really smart guy, you know, really proficient at languages, and he was really influenced by this little college language called Scheme that I think MIT developed or some other, you know, fancy college developed. And he did it in 10 days. 10 days is not a lot of time. 10 days is not a lot of time to think about things you may be getting wrong, to fix mistakes, to do things like that. So there were a lot of things that were really great ideas in JavaScript, and there were some things that weren't so great ideas, and they all kind of went in because there was just 10 days to do this. The other thing that went on is, as I said, it was influenced a lot by Scheme. Now, the interesting thing about Scheme is not a curly brace language, so it doesn't look like C or C++ or Objective-C or Java. And Sun didn't like that. And a lot of the marketing people at Netscape didn't like that because they knew that all the popular languages were C-based. And so they, you know, had Brendan make some changes, replace the parentheses with curly braces, make it look a little bit more like C. And then they thought of the most brilliant thing ever, which was to change the name. They said, you know, if we call it JavaScript, people will think that it's a light version of Java. Everybody likes Java. It's going to be the language that's going to power devices everywhere. You know, Sun had this big marketing campaign that was in full tilt at that time. So they changed the name, and that caused a lot of problems. And the main problem is that if you learned Java and somebody said, well, can you do JavaScript? In your head, you're thinking, this is just a light version of the thing I already know. So yes, I can. So for just a little historical context, here's what a Scheme language program looks like. Just a simple hello world. Doesn't look like anything like JavaScript looks today or like a C-based language. But that's basically what it looked like. It was all parentheses, no curly braces. So then we move on to the next question, which is, why is good JavaScript so hard to write? And there's a big, giant difference in JavaScript. Even at the company where I work, at people that I've consulted with, there's a lot of really smart guys who are brilliant in C# and horrible at JavaScript. And the reason why good JavaScript is so hard to write is simple. It's your fault. My fault. Pretty much most people that have ever tried to code in JavaScript, it's their fault because of a few reasons. Starting off with, JavaScript is a language that has a really odd facet to it. It's the language most engineers don't bother to learn because we think we already know it. You know, we put in a for loop. Hey, the for loop works exactly like we thought. Okay, it doesn't have integers, but it has this thing called var. So I'll create some vars. Hey, it holds exactly, it does pretty much everything that you think it does when you hit it at the shallow level. And later on, that's gonna bite you in the butt. But you know, because engineers don't bother to learn it, we make a lot of mistakes. And worse, we teach other people those mistakes. So you'll have whole companies where their whole entire client-side code base is crap, and they don't even know it. They can't figure out why it's so slow, and so they blame JavaScript itself. Well, JavaScript's really slow, you know, it's interpreted. Also, I would say that it's a lot has to do with the fact that JavaScript is a language which is changed instead of embraced. By that I mean, people come out with plugins and with libraries like Microsoft had the Microsoft Ajax library and other plugins where they essentially made JavaScript into a mini C#. It was great. You didn't have to learn JavaScript at all. You can create objects, you can do all this other stuff, you can make Ajax calls, you can iterate through things, you can do all the things that you are familiar with doing with the C#. Only problem was it made really bad JavaScript that was extremely slow. And once again, who got the blame? JavaScript got the blame. Why is this so slow on the client side? Well, you know, JavaScript's interpreted. That makes it slow. And then the other thing is that goes on, and this is one of those things that most people aren't aware of until they start writing single page apps. And by single page, I mean there's no page load. Once the browser loads in data from your server, after that it's all Ajax. Is that the page load has protected you. A lot of times people have things like memory leaks, or they have poorly performing code, and they have things that are not garbage collected properly, or they're doing something else weird. But luckily, right at the point where the computer was probably going to crash, the user hit the submit button or hit the link to the next page, and that wiped out the browser and grabbed a new page worth of stuff and buried all your mistakes, like the mob does dead bodies at sea. And you know, those little mistakes just disappeared, and you never knew how close your app came to crashing. The browser wars. So right now we're in what I like to call browser war number 3. So far, you know, this first one that started off was back in the 1990s, and it was between Microsoft and Netscape. And if it seems like I'm trying to pay the tale to all of you would-be engineers that are entrepreneurs and would like to do battle with Microsoft, I kind of am. Work with them, don't work against them, because people that work against Microsoft don't normally last too long. So Microsoft and Netscape, Internet Explorer versus Navigator, everybody wanted control of this thing called the Internet, because it was this vast, untapped field, and you could sit there and literally, you know, watch how fast it was expanding. You know, it went from this thing that only a few, you know, engineers and college nerds knew about in 1990 to 1999, fueling this .com bubble that was, you know, powering the United States, actually shaking the economy itself. That's an amazing thing to do in just 10 years worth of growth. And so, of course, everybody wanted it. Microsoft wanted parts of it. Netscape, who was this new upstart kid, wanted parts of it. And you know, what they were doing at that time was they were coming out with proprietary extensions to their browsers in order to fight each other. And they were doing dirty tricks. Microsoft was a little bit better at the dirty tricks than other people, because they would just do simple things like say, hey, you've got a website. If you just put this little snippet of code in your website, you can get free Microsoft swag. All kinds of expensive stuff that you could never, you know, afford on your measly website's budget. And what did the little snippet of code said? It'd say things like, if you hit their site with Netscape Navigator, hey, you should be using Microsoft Internet Explorer. It's much better. Or this site only supports Microsoft Explorer. And
I want to challenge you. Netscape still exists. It just doesn't look the same, because Mozilla is still around and AOL is still around. And that's, Netscape got bought by AOL, so they took the name, and Mozilla took the browser and they ran with it, and Mozilla is doing just fine.
You're absolutely right on one part of that. I would agree that, yeah, Netscape Navigator still exists. Netscape itself doesn't exist. They open sourced their software to the Mozilla Foundation, and it eventually became the seeds of what we now know as Firefox. And then I would argue with you on how well AOL is doing. But yeah, I mean, it's sort of like the dinosaurs. Dinosaurs became birds, according to some evolutionists, and that may or may not be true. But dinosaurs don't exist. You're not going to see any T-Rexes walking down the street.
There actually is a build of Mozilla called Netscape still.
Yeah, and how well is that business model doing? But yeah, I mean, I do agree that they did open source their stuff. It's kind of like you could say, hey, the HP tablet still exists because they open sourced the software, but no one's really building anything. Mozilla did, use it as a kernel to become Firefox, and I would probably say most of the code base at this time has probably been completely changed, but it did serve as the seed. Right now, on the desktop, the second browser war is still undergoing, and this is between 4 big competitors: Microsoft, Mozilla, Google, and Apple. And they're of course IE, Firefox, Chrome, and Safari. And people don't realize how valuable search is. Search accounts for something like 90% of Google's multi-billion dollars. This is why none of them want to let this market go. Because if I can even get just a little bit of couple of billion dollars a year, that's still a lot of money. And so in this case, Microsoft is actually kind of getting whipped. And it all depends on how you do the numbers. So there'll probably be a guy here next month who might argue the opposite, that says, hey, Microsoft's doing just fine, because if you tally up all the versions of IE, they're still bigger than any one of their competitors. But if you take just IE versions by themselves, none of them are beating Chrome right now. And it all depends on, like I said, how the numbers get skewed, how people do them. It's still kind of close. It's pretty much a 4-way tie. And it's all about billions of dollars. But luckily, in this case, instead of changing their browsers to support only proprietary tags, people are getting more and more into this idea of supporting the standard. And the standard becomes this measure that's being used to compete against how fully implementing the standard you are, and how fast you are becomes the things that you use to measure and compete against each other. Which leads us right into the third phase of the browser war, is mobile devices. And one of the things that people don't realize, I work for Kelley Blue Book, and at Kelley Blue Book, mobile devices account for, depending on the day, anywhere from 18 to 25% of our traffic. But that number is growing at a rate where we're predicting somewhere between the next 4 to 5 years, it will be the majority of our traffic, if it keeps going pretty much the same pace that it's going now. Because people like having information at their fingertips wherever the heck they happen to be. And so that's a big factor of why everybody's browser is trying to compete, because once again, search and referrals is worth a lot of money. And so if you say, hey, Google made, $20 billion last year off of desktop searching, and you're predicting that mobile devices will outpace desktop devices, in 5 years, there's $20 billion that could be up for grabs there. And that's why these companies are fighting so hard for them. And right now, it's just based on number of devices in the last few years, and I'm only counting smartphones. I'm not going back to the feature phone days where a lot of the feature phones have browsers, but they were pretty remedial compared to the browsers that are on the phones today. It's a 2-way tie between Apple and Google. And Apple actually has still the better technology, and it's mainly because of, initially when the iPhone came out back in 2008, the only apps you could write were web apps. And so Apple put a lot of hooks, both meta tags, which are proprietary, and also just more support for HTML5 stuff in order to make their phone apps, their phone's web apps, seem really, really close to being an app itself. Any questions so far? Everybody all right? Haven't put anybody to sleep? Okay, so one of the things that protects us in JavaScript is to use best practices. And so there's probably hundreds of best practices we can name, and I'm just going to stick to 4 main areas. One is to avoid sloppy JavaScript, avoid the global space, encapsulate code into objects, and to use design patterns. And so now we get to look at some actual code. As far as avoiding sloppy JavaScript, you have 4 main tenets that I'm going to talk about. One is to, first off, JavaScript is a harsh mistress. There's no getting around that. It will confound you sometimes. Probably the #1 bug, at least that we used to have in our code, is the always using triple equal signs or the bang and 2 equal signs and not 2 equal signs or a bang equal sign. And I'll show you exactly why in code why that is. Also, you've got to try to code in JavaScript and not in C#, not in Java, not in Ruby, etc. And the final thing is you got to use some sort of linter. Back in the old days of C, when compilers were really slow, back in the glory days, because you could say, your boss would say, why are you out here? Well, the compiler's building, it's going to take it 20 minutes, so I thought I'd stretch my legs. Nowadays, with freaking compilers that compile in the background, as soon as you hit the arrow, it's ready to go, and there's no break. So you got to use some kind of linter, and JSLint does sort of like the old school C and C++ linters used to do. It will go through and validate your code without doing some kind of compilation and point out errors and mistakes. And all of these linters, whether it's JSLint, JSHint, Google Closure compiler, they'll tell you things, and you can kind of set flags on them to say how strict you want to be, because some of them go crazy. You know, they go a little too strict, and it's usually best for all the members of the same team to agree on a set of how strict they want to be. But let's get in and let's take a quick look and see what I mean. The very first thing that we talked about is how harsh of a mistress JavaScript can be. So what we're going to do here is just put an intentional mistake. Now, you'll notice that my code suddenly lit up in red, and that's because I actually have JS. Oh, sorry. Let's put this on the screen. Thank you very much. Okay, so we've put an intentional mistake. We've changed a semicolon here to a period. Now, my code's turning red because I actually have JSLint built in, so you'll have to pretend that it's not actually there. And let's see what happens when we actually execute this small example. Let's put this guy for this one. So in the browser, absolutely nothing occurred. But when we look at the console, and trust me, your users are not going to look at the console to see if you made any mistakes and give you a friendly phone call and say, hey, I think you meant to to do this, and my browser's saying you did this wrong. So in the console, in the browser, nothing happened. In the console, we can see that we've got an uncaught type exception, cannot call method log of undefined. That's not very helpful. So the very first case, it doesn't give you any warning at all in the browser. Even when you use the developer console, it gives you an error message that doesn't make any sense. And this is part of what I mean when I say it's a harsh mistress. If you do something wrong in JavaScript, it is standard behavior for all the elements of the web that when they encounter something that they don't understand, to keep rolling. Hopefully get to the next statement I do understand. And the main reason is because in the early days of the browsers, most of them were hand-coded by people that really didn't know what they were doing, so there was lots and lots of errors. It wasn't like today where you had CS5 or you had Visual Studios. You had other stuff that could do syntax checking to make sure your tags match and things like that. So it was much easier to make the browsers more forgiving than it was to educate users to write better code. So browsers tend to ignore errors. And so if you make a mistake, it's up to you to figure out, first off, that you even made a mistake, and then secondly, what the mistake you made was.
Do you say ignore or just stop processing?
There's two different ways that it'll handle stuff. So in the case of JavaScript, the line that generates the error is where it terminates a method call. So for instance, if this was a function being called by another method, it's going to stop at this line that says Bob equals Bob, period. And this next line, console.log, does not get printed. If that happens to be the last, and this is actually one of the things that makes it so bad, is that if this happened to be the last line of a method, everything else in the method worked, except for that last line, and you may not even notice that you had some bad code. On the other hand, if it's the first line of a method, suddenly nothing else happens, and then you might be a little bit more clued in. And especially when you're dealing with event-driven code, which a lot of browser code is, where the user's clicking on something or doing something and you're responding to it, depending on what method is bad, you may not notice at all.
I've seen once I hit an error like this, then even a simple button click doesn't work anymore.
Right.
JavaScript is done.
Yeah, because it probably it hit the error before it had the chance to do all the initialization routines or something else like that. So you always want to make sure that you first off that you're aware that when JavaScript fails, it will fail silently. Unless you can put try catch blocks on stuff, and I have mixed feelings sometimes about that. I think that it's good when you're doing development, but I think it actually slows things down when you're doing actual coding. And then the other question is, when you catch an exception, what do you do? Because what happens if it's during a point when you're doing an AJAX load? What can you do? You can't finish the loading of the data, and if you tell the user something, it better be something that's really simple and means something to somebody. Like, best that you can do is say something like, you might want to hit Control F5, try this again, reload this thing, and hopefully, the site is up again. And so it's very, problematic as to what to do at that point, but it's always helpful to know that when you fail, when you make a mistake, it's not going to tell you. Like any good mistress. The next thing is going to be to always use the triple equal signs or the bang and double equal signs and not their double equal counterparts. So let's take a look at this. This is going to be a little bit of a trip through the looking glass, my friends. JavaScript has a thing called type coercion, which means that if you use double equal signs, it will try to make the types on both sides of that expression the same. And it does some magic that's not exactly logical in your head. So when we take a look at this code, and bear with me, I am praying to God that nobody here will ever write any code that looks like this, but it's very good to explain what exactly is going on here. So let's take a look at the first expression, which is we're going to compare a 0 to an empty string. In your head, you're thinking, of course they're false. We're going to compare a numeric 0 to a string 0. We're going to compare false to a string 0. We're going to compare null to an undefined. Now in JavaScript, undefined is a type, and it just means that a variable or some expression hasn't had a value set to it at all. And then finally, we're going to compare a bunch of white space characters, a tab, a return, a carriage return, to 0. Now, like I said, this is a trip to the looking glass, and you just have to bear with me on this one. So when we run this expression, guess what? All of those are true. Each and every one of them is true. And that's because of the magic of type coercion and a little thing that JavaScript has that most people aren't aware of when they first encounter JavaScript, is that Normally speaking, in binary expressions, you have true and false. Well, in JavaScript, they have a true, a false, and a falsy. And falsy is the one that is, if you learn how to use it and tame it well, it's great. It helps your code to be a lot more performant. You can make your code a lot faster. And actually, if the person that's reading it understands JavaScript, it actually becomes more clear, because you can simplify a lot of your comparisons by, if you have a number, if you're doing a countdown from 99 to 0, rather than saying each time does the number equal 0, you can just say the number, because as it's counting down, when it becomes 0, it becomes falsy, and now the expression is no longer true. And that simple change in comparison can actually increase your performance on loops that are run a lot. So what happened in our code is pretty simple to understand when you understand the notion of falsy. And falsy is anything that is 0, empty string, null, or undefined. And because an empty string is also considered white space characters, and 0 is also considered to be a falsy expression, when it undergoes coercion here, all of these things become falsy, and they become equal to each other on both sides of the equation. This is the reason why on my team, we never, ever, ever use this double equal signs. We always use triple. And I cannot think of a good reason to ever use the double ones. And if you do think of one, because you might have some things going on that are different than the things that I'm doing, I would also highly recommend you put a comment in that says, I know I'm using double equal signs, so that the next person that reads it doesn't, that understands that there was some intrinsic reason why you did that. So if we go in here and we then say, hey, let's just replace all these guys back. And so if we run this expression again, now they all magically become false, as what they should be. And this is really important. Coercion will cause you problems, and it will, and if you're not thinking in JavaScript, it will defy logic, what's going on. And so it's just always a best practice to always use the triple equal signs. The next thing that we need to talk about is what you're coding in. It's important to code in JavaScript and not C#. What I mean by this is a lot of times people get so familiar with the language such as C# that when they start coding in JavaScript, they try to find things that are similar. So they say, hey, it's got a while loop. We've got a while loop in C#. We've got a for loop. They've got a for loop. Hey, we've got a for each loop. They've got a for in loop. And for some reason or another, everyone I know that loves C# loves the for in loop and doesn't realize that it's a trap. It doesn't work the way that you think it does, and it causes lots of bad things to happen. And a lot of times, you can write the code and the code will work right, but it won't work exactly the way that it reads. And that's a problem in my eyes, that the code should always read fairly clear. So here we have a very simple, two simple functions. Now, right off the bat, I can tell you that this function, this is what's called an anonymous immediate function. It's anonymous because it doesn't have a name. It's immediate because it's got these parentheses, and this parentheses cause the browser to execute this function as soon as it sees it. This is one of the ways that you avoid polluting the global space. Anytime something doesn't need a name, you don't need to give it a name. If you just need to establish some hooks for events or whatever, and it doesn't need to ever be called again, it's best to wrap it in an anonymous immediate function, and then that way it doesn't pollute the global space and make your program at risk of getting in naming collisions with other pieces of your code. So what we have here is just two for loops. Well, we have a for loop and a for in loop. In each case, we're gonna create an array in both of them. The fifth element of the array, we're gonna set equal to test in both of them. We're gonna say, hey, what's the length of this array in both of them? And in both cases, the length should be 6 because we created an array, we assigned something to the fifth element, so now it has to be at least that big. Now, just understanding, a little bit of JavaScript that's been presented tonight, it's fairly certain to reason out that in this first example, the elements 0 through 4 should be undefined because they haven't been set to a value yet. And element number 5 should be test. When we look at this second example, a lot of this stuff seems exactly the same, except for we did add one thing here, which is we're setting an array.prototype.some variable to a string. And we might not be sure what that means, but just remember that this guy here, my array, is an array. Prototype is one of the ways that JavaScript does inheritance. It has what's called prototypical inheritance. And then we're going to do this loop through all of the objects that are in this my array and print them out pretty much the same way that we do here, except here we use the index, here we use the name of the object. So let's see what happens. Okay, so let's step through this. We start off in the first one, and we get the length of 6. We get the 4 undefined, which we were expecting, and we get number 5 is set to test. Everything there worked pretty much the way that we reasoned it out in our programming heads. On the second loop, we have a length of 6, which makes sense. Suddenly we have element number 5. We don't get elements 0 through 4. And suddenly we get this guy, which is some variable, where did this come from? And it doesn't have anything that says, what it's being set to. This is what's wrong with using the for-in thing, is that two things. One, when used on an array, it's not going to loop through the array the way that you think that it will. It's only going to do objects that have been set because it's meant for objects, not for arrays. And so it's actually meant for object literals, not just for arrays. So it's only looking at the objects themselves. And even though we created this before we created the prototype for it, it still picks up that prototype that it inherited suddenly. That's one of the weird things about the way JavaScript does inheritance, is that when you assign something to a prototype, everything that derives from that object picks up that thing immediately, even before you do a new. And the main thing that makes this kind of code bad is just simply because it does surprising things. And as engineers, we don't want to be surprised by what our code does. All of our code should be as clear and as clean as we can possibly make it, especially later on when we're reading through it, trying to either add something or fix something.
Hey Troy.
Sure.
Dealing with lists in JavaScript is actually one of the things I absolutely hate. And I was wondering if you could point me in the direction of something that might give me like Lambda support or some sort of easy way to query collections in JavaScript.
The clearest way that I can think to do it off the top of my head, and the question was best way to go through lists in JavaScript. I like the underscore library. It has a lot of set and list manipulation methods on it. To both sort through, to rearrange, to pluck things out of it, to remap them, and I use it quite a lot.
So it's circular without having to iterate through the entire thing?
You're still going to do some iterations, but it has methods that, it's going to internally iterate through them and pluck the things out that you want. And so it's really good for remapping things. So you can say, hey, I've got this list of objects here. I only want the ones that are greater than this date. So you can do things like in C# with both your iterators and your comparators. So you can pluck things out and do comparisons and do that kind of stuff on them. And it's the underscore library. And it's actually really small. It's like 4K. and it does quite a bit in that 4K. The final thing that I want to talk about before we go on sloppy JavaScript is just JSLint. And as I said before, there's a bunch of these different linting programs. JSLint is just one of them. It's the one that I kind of use a lot because the guy that wrote it has been sort of like my JavaScript remote mentor. And he's a guy named Douglas Crockford. So he used to be the chief architect at Yahoo. Just recently he left. Now he's a chief architect at PayPal. And in fact, if you go to Yahoo Theater and just do a query for Crockford, there's probably a good 20 videos from him that'll teach you more than I ever could on JavaScript. Although they do get kind of a little ethereal, esoterical. Because a lot of times you'll go, well, why would I want to do this? So JSLint, like most linting programs, is a very simple program. You can just dump stuff in it. It also has a component that you could download, and so you don't have to go to the website in case you don't have access to the internet, or maybe you're working on a plane, or as they always like to show in commercials, at the beach with your laptop. Although I've never known why I ever want to do that. But in the simplest form, you just dump some code into it. You tell it to do its linting, and if you notice down here, there's a bunch of checkboxes. So this is where I said that you can do things like say just how obscenely strict you'd like to be. Because there might be times where you go, you know what, I understand that the eval operator has some evil to it, but I'm willing to live with it because I need it for some of the things that it can do. And eval is basically a way that you can dynamically create more JavaScript code by strings. And that's part of the reasons why it's evil, is that it could theoretically, depending on how you use it, if you were silly enough to do some parsing of a string expression that a user typed in, and that user was, diabolical, he would type in a program that would cause your, give him control of your application. So you can set these things on and off the way that you want them, and I always tell people, you should do these kind of things as a team. If you're working as part of a team, everybody should agree to things, because the number one thing that I find when new ideas fail in team is when any one person was not included in the decision making, or at least had a say so, because people will go, well, they're not gonna, when I was hired we weren't doing that, and I don't see why we should have to do it now. What I've been doing for the last God knows how long works just fine, so I refuse to participate. Now, right off the bat, we get a few errors, and I actually expected this error. One of them is that JSLint wants to see everything up front before defined before it gets used. And so, like in case of console, which is something that exists already, what you have to do is tell it things like console, and that tells it that this guy exists somewhere already. And so it tells me stuff like, okay, well now we've got I anonymous 5, well this isn't used, which is actually helpful. In this case, it's telling me that one of my variables, I, here, is not actually used. And that's actually a helpful kind of a thing, because it helps you get rid of some of the code that's not doing anything. The Google Closure compiler does this even better, because it gets a good snapshot of your whole application. So you can have JavaScript application that's composed of multiple files, and as it crunches them all together, because it also compresses things and makes them smaller, it takes a look at your whole entire application and will say, hey, you got this function print number, which is never called by anything, and that way you can get rid of it.
Which tool is that?
The Google Closure compiler.
Google Closure.
Yeah, if you go to code.google.com, you can look up the Closure compiler, and it also has, you can download it as a jar file. You can dump stuff into it like this guy here, or you can, it actually has a web service also, so if you wanted to call its web service in your make process or whatever, but I'd rather just download the jar and call the jar during my makes, so that it can compress stuff. But that's just a short, quick introduction to what a linter does. And like I said, it's up to you how tyrannical you'd like to be. And I usually play it fairly strict, but there's a couple of things like it has spacing suggestions, and those don't mean anything to me, so I usually turn those off. continuing on our best practices, we want to avoid the global space. And the global space is any function or variable that is not defined inside of something else exists in the global space. So when you see a var x equals y or something like that, that's in the global space. If you see a function, print number, that's inside of the global space itself. So one of the things that we do a lot is, and there's a couple of different methodologies of how you avoid the global space, but the one that I prefer to use is I like object literals, and we pack pretty much everything into object literals. And by that I mean like this. So right off the bat you can see that I'm already used to using the linter, although I should use the function form of the lint expression and not the string. And I define these variables up here just so the linter knows that they exist already, so when my code goes through linting it can pass. And then the next thing that I do is I define this thing called rock encoder. And this is a rather curious expression. You see rock encoder equals rock encoder or an empty object. And what this is we call this a default expression. That's not an official name, it's just the colloquial name because of the way that it is used. And the way that it is used is that, remember once again that JavaScript has that notion of falsy. If this guy doesn't exist, he's undefined, and undefined is falsy, so it'll pick up this side of the expression, creating an object literal out of it. If he does exist, we'll just use whatever's there. The reason why I do this is because a lot of the times, and it all depends on what kind of an application I write, but just to keep myself from making mistakes, I try not to make my code dependent upon the order that it's loaded in. And so I know that somewhere, someplace, this guy is going to get defined. And just in case he got defined in another module, I don't want to wipe it out. I want to keep it alive and just add more stuff to it. And because when you use, Google has a lot of tools for loading stuff, and also, but the order that the JavaScript's going to get loaded is not guaranteed in that case. In the browser, it's guaranteed. If I put a.javascript, b.javascript, and c.javascript, all this includes and a script tag, they'll get loaded in order. But there's other tools that can do multiple loads of JavaScript files, and I use those a lot. And because of that, I always try to make my code so that it's never order dependent. So all it needs to know is that everybody's existing, and then there's usually something that hits a flag that says, okay, we're ready now. And then that flag is usually an event. And this is pretty much the way that things like jQuery work, and jQuery mobile especially works, that it throws an event that says, hey, I'm all set up, I'm ready to go. For people that program PhoneGap, PhoneGap does the same thing. It just has a bunch of JavaScript that's running, it's initializing, but once it's ready, it triggers an event, which is a ready event, initialize ready event, and at that point, it's actually good to go. So once we create our object literal, we just put everything from this application gets packed in there, that everything that's not an anonymous function that I might need a handle for. So that's one way of doing it. Now there's multiple ways of doing namespacing in JavaScript, and one way is actually to stick everything inside of a function. And if you do everything inside, for instance, of an anonymous function like this, and anything that's defined inside of this function only exists within it. That doesn't pollute the global space. That's kind of the way that jQuery does stuff. jQuery does it. A lot of plugins do it. And what they do is they wrap all of their code inside of a single anonymous function. They define all the stuff that they need. And in the end, jQuery assigns just two global variables, jQuery and the $, which is also equal to jQuery. Those are the only things that get exposed to the outside world, and everything else is an object that's trailing down from that. And I know this gets a little bit ethereal, but it's the way that you kind of protect yourself, because anything that sits on the global space, there's a chance that, for instance, if you decide to name a function, accept user input, what are the odds that somebody else on your own team, or somebody else in your own company, or somebody else on the internet is also going to have a function that's called accept user input, or print document, or call home, or do whatever else? The more general you make it, the more likely it's going to be. And so namespacing helps protect you from the side effects of that. And the side effects are actually kind of nasty, because whoever gets defined last wins. So if you have two different methods, both called printout, yours does one thing and the other guy's does something else, and only his comes second, is by evaluation of the browser. Anytime you call printout, it's calling his. And you don't get an error at all on that. It just works, but it doesn't work right. Okay, so we talked about using namespacing, minimizing use of global variables, about anonymous and media functions. Then we get into design patterns. And design patterns are just the same gang of four plus, 20 years of design patterns that are familiar in any language. And one of the reasons that I like design patterns is just simply because I'm lazy. I'm lazy, I don't like to have to document stuff, and if I can find a good pattern that matches what we're doing, or what we need to do, I can say, hey, we're going to use a mediator pattern to handle the navigation of the screen, or we're going to use a publisher or excuse me, an observer pattern to do event notification or whatever. And guess what? All of my developers can look it up. And I don't have to go into details about how it works. They not only can they look it up, they can get smaller examples of, if they're like, oh crap, I don't know what that is, at the end of the engineering meeting, hopefully before they have to code something, they've looked it up on the internet, they found a bunch of examples, they wrote some smaller example programs that got the notion clear in their head, and and then they can have something to get it from. But I prefer to use patterns that other people have already done, and it's also part of the reason why I like to use plugins, because I like code that has already been battle tested. I don't have anything against innovation. If you come up with some way that you think is really good and you're willing to explain it and and put in the hard hours, but on the other hand, almost everything that I do at work, there's a time component to it. Oh my God, we got to get this done today. Can we get it done today? Can we push it out to the public servers today? And so I try not to do too much research while I'm at work. Instead, I get things done. And I love things like plugins because they've been banged on by millions of people all over the world, and all of their little faults and foibles are usually documented by other people, and I can just read through them and say, can I live with this thing? And so, of course we have, as far as design patterns are concerned, we have the singleton, and singletons, and a lot of times, it all depends on how lazy I want to be, because I can actually create a singleton object that if you say new to this object, it'll always just return you the same reference. But the honest to goodness truth is, in JavaScript, I use new a lot less than I do in like C# or in Java. And the main reason is because normally I can create my objects on the fly. And so there's no real reason for me to do a strict pattern of sticking to something. I used to do that when I first started JavaScript, especially when I was under the influences of a company in Redmond, and I would just listen to what they said. But nowadays I find that I don't really new that many things up, except for when I'm writing games. But the other stuff, no. The main pattern that is important though in JavaScript, and you'll see this pattern a lot, especially in plugins once again, is the chaining pattern, which is just pretty much familiar to everybody these days. In fact, let me go back to this guy. So in jQuery uses chaining a lot. This reads as, we're trying to find an ID that is called my panel on the screen. Once we find it, we're going to try to find the table and get the class called first column within it. We're going to remove that class first column. We're going to change the background to red, and then we're going to append to the end of this thing, this cell is now red. That's what a chaining operation actually looks like for people that are a little bit more familiar with C#. Here's one kind of linkish. This is not actually a link expression. This is just a string. But because of the extensions that were built in for a link, you can do stuff like this where you replace antelope with centipede, you get the substring of aardvark, you just do a bunch of operations on the same object. That's what chaining's about. Some people could argue whether or not it really saves anything at all, but I just hate repeating myself. So the other way to do this would be to assign this guy to a string and then just repeat down these different operations on this string, setting it back to equal to itself and so forth. And I think that's a little bit more kludgy looking. In JavaScript, we can also see this. I have a quick example here. Art, what time do we usually take a break?
We usually take it 1 minute per minute, but that's a good time for you.
Let's make now a good time. So
Get a break early.
yeah, let's take a 10-minute break, and we'll continue on here. Okay, so when we left off, we were going to talk about chaining, and I was going to give a quick JavaScript example of some chaining. And both quick and simple. So in this case, we're going to take a function, and our function is called ob.construct. Ob.construct. And in this case, inside of here, there's a bunch of things that are being defined. And the key thing to remember is that all of these guys return this. So they're basically passing back the object that's coming into them. This in JavaScript mostly works the same as what you would think it does in other languages, except for when you do event handling. Then you have to be really careful. But in this simple example, all we're doing is we're taking this thing called object, and here's one of the ways that you actually create objects in JavaScript is that you new up, and you notice that object construct is a function. But in this case, functions work like are object constructors. This is like my C tool. And we assign it to obj, then obj we call its function 1, we call its function 2, and its function 3 just in a chain. And all of these guys, all they do is do a console log out, passing in their name and whatever we pass in. And then the last thing that they do is return this, and this is what gets passed on to the next function so that it knows what it's a dot function of. And this pattern, of course, works really good when you're chaining things together. Usually, like in something like jQuery, there's a point where the pattern will get broken. Like you'll have a bunch of expressions, and then you'll do something like take the width. Well, once you do the width, what's being returned is a number, not an object, and so you can't chain after that point. So you just have to always remember that. And in jQuery, they're really good about specifying out which ones of their functions actually, return and are chainable, and which ones are not. And you can also tell by what they return. If they return, a value, then it's not chainable. So if we take this guy, go back to our magic browser, make him active yet. And we get exactly what we thought we would get, which is just chaining function banana, apple, banana, carrot. And this is just a very simple example of chaining, and it's a good pattern, and it's a good pattern that's used a lot. And like I said, it's always handy to know. The final pattern that I use a lot is the, first go to the right page, is the revealing module structure. And one of the things that's interesting, of course, in JavaScript and pretty much every other language is that things get named by the person who taught you. And so a lot of these things are still kind of like it's not really have an official name. It's not like the ECMO board sits down and gives names to design pattern. No, it's usually the person that thought of it, and then he taught somebody else or wrote an article or wrote a book or wrote a blog. And so these kind of things, I've seen them name different things. And the one that sticks in my head the most is revealing module structure, just because it sounds really complicated, and I like things that have really complicated names sometimes.
What would be a simple name for
Well, let me show you what it is, and maybe you can come up with a good name.
Call it Troy.
No. So in this case, what it is, a revealing module structure, is that, remember that in JavaScript, there's no way to do information hiding. There's no protected, private, or any of that kind of stuff. So one of the ways that we hide things is we stick them in the functions. Now the question is, how do we get things out of functions? Because, you know, any kind of a class, if a class has no public methods, unless it's just hooking an event, it doesn't really do anything for the outside world. So the way that we get stuff out is we actually pass it out in an object literal. And in this case, we have a method in here called page show. We have another method called page hide. Both of these guys are visible to the outside world. And they're visible because we're going to attach them into the end of this touch me object. And so if you go rock encoder pages.touchme.page show, it's this guy. And page hide. Now the names on either sides of this key value pair, they don't have to match, but because I code sometimes late at night, I sometimes code under the influence of alcohol, when things don't make as much sense as they should, I like to be sure that I'm as clear about things as I absolutely positively can be. So in this case, I always set the name that is visible from the outside world exactly the same as the name that's visible to the inside world. Now, you also notice that there's another method in here called calculate sum. This method is not visible to the outside world. There is no way for something on the outside world to reach this method. So if we take this guy, and this thing is going to do some, I'm not exactly sure what it's going to do, but what I want to do is actually just bring it up and show you the things that are and are not accessible. And so we go. So if we go in and we do an inspection, we go to our console. One of the reasons why I do like Chrome as a browser is that I can do stuff like this, interrogate my objects. And you notice we've got pages, we've got our touch me, and if we click on touch me, we can see page hide, and we can see page show. And I'm sorry about the smallness of this. I eventually have to figure out how to do this zooming of this thing, and I still don't know. But those guys are visible, but calculate sum is not visible. There's no way to access it from outside of that method, outside of that object. Only these two guys that we want to be visible are visible. And that's one of the ways, that's why the revealing module pattern is so useful, is it's a way to do information hiding.
And not through the global space.
Absolutely. So now we move into our final section here, and we're going to talk a little bit about unit testing. We'll talk about, give a quick introduction to unit testing. I'll talk about headless unit testing and what that means. As I said, I like things that are either complicated sounding or funny sounding. Actually, I take that back. This is our penultimate section. And we're going to talk about different JavaScript unit testers. So a unit test is a piece of code that tests a piece of production code. And I always put the emphasis on production code, because I've seen a lot of different people do these kinds of things different ways, and they come up with different ways to test it. But to me, the proof of the pudding is that it has to run the code in the environment that it's going to run in. Because if you don't, if you're just testing it, for instance, if I'm testing on Chrome but I'm running on an iPhone, most of the things are going to work right, but there's probably going to be some differences, and I won't know what those differences are. I could say that theoretically it should run on the iPhone, but I cannot guarantee it. And to me, that's kind of like telling somebody, we've done all the math, and we're pretty certain that we've calculated the speed of the bullet, we've calculated the resistance of the Kevlar vest, and we're sure that it's going to work. So please put this vest on, and I'm going to shoot a bullet, and let's see if it really works. And most people would be a little bit hesitant of going, yes, I'll volunteer for that test. And if you don't test your unit test in a production type environment, or as close to it as you possibly can, you're kind of stepping back one step. So of course, a unit test, it's, the basic steps are just going to be that it sets up one or a few more objects in a known state. It's going to exercise them, inspect them, inspect the results, and the most important thing, at least to me, is that it's got to be fast and it's got to be easy to run. All of us as engineers have gone through the we just need to get something done phase of, I don't need any, please don't interrupt me. I don't care if what you have to say, unless you can say it in 0 time. Don't stop. I've got to get this done. The deadline's approaching. And if somebody now says that you've got some complicated procedure to do a unit test to add on top of the things that you're already feeling stressed about, guess what? You just aren't going to do those unit tests. They're going to say, did you run unit tests? Of course. I wanted to. Now, by headless unit tests, and my reasons for saying beware of them, is that a headless unit test is Java that runs outside of a browser. If you're writing unit tests for Node, for instance, it's fine to use a headless unit tester because it doesn't run in a browser. But the browser changes a lot of things, and a lot of the issues that you're going to find sometimes are going to have to do with the interaction between JavaScript and DOM code. So if you're running unit tests that are running outside of a browser, you're really not testing your code. Also, keep in mind that although the browser wars were at a quieter period than what we used to be at, browsers are not identical at all by any ways or means. And we've seen browser differences not just between the different major vendors, like you would expect there to be differences in browsers from Google and from Apple, but one of the worst bugs that I've run into, that I still sometimes curl up in a ball and sob softly to myself when I think about it, was between 2 different versions of the Samsung Galaxy 2. One for AT&T and one for Verizon. It worked perfectly on the the Verizon version, and we were having issues with the AT&T version. So even though this is supposed to be the same phone, it's supposedly the only thing that's different is that, one's running on Verizon's network and the other one's running on AT&T's network. Something changed in the browser and it broke our code, and it took us quite a while to figure out what was going on and how to do a workaround, and the actual issue was with CSS. But, for that reason, I don't like headless unit testing. Headless means that, like, the Ruby people, and I don't know how many people here are familiar with Ruby, but Ruby's actually a great little language. And you can write some pretty good websites with it. The only problem is I don't know if it'll ever get to that point where it's more, well, a lot of people do use it, so I won't say anything else. But they're really big on unit testing, and that's one of the other things that I liked about unit tests, is that the Ruby people, but their favorite way to do the unit test so you have this Ruby, Ruby's on the server side, JavaScript's on the client side. They would use Rhino, which is a Java interpretation of JavaScript, and to run their tests. And that's all well and fine, and they validated that the logic of their JavaScript was fine, but not that their interactions with the DOM were fine, because there was no DOM. There was none of that interaction layer, and also there's still some slight differences between browser, the actual JavaScript itself. I've also seen versions of this same kind of thing done on the in the Visual Studio Land. There was an article, I'm trying to think of who did it. I think it was in Code Project, where they showed how to use the test engine or the JavaScript engine from IE in Visual Studios to do unit tests of your JavaScript code. But once again, it's running without a browser in there, so I question how well it's actually testing what's going on. As far as actual JavaScript unit testers, there's Jasmine, which is actually, a lot of people really like it. It's got kind of a more wordy feel to it. There's QUnit, which is by the same guys that do jQuery. It's, in fact, what they use to write jQuery, jQuery UI, and jQuery mobile test in. There's UE3, which is from Yahoo, the Yahoo user interface 3 test. And then there's the final one is JS Test Driver, which is the one that I actually prefer to use. And the main reason why I like to use it is that it runs tests on all the browsers that my code is going to run in. So I can run tests on this device. And the way that it works is, and part of the reason for its name is that it sets up a server, and then it passes some. All you do is you just access a certain URL, and now your browser is slave to this server, and it'll send those JavaScript down to your browser and execute the code on your device. And that to me is a very powerful reason why I prefer to use it. And we have still, even to this day, we'll see ones where everything else seems the same, and we'll see it fail on just one device, and usually it's something because we're doing something crazy like the for-in statement, and we were expecting things in a certain order and they didn't come out in that order. And I say, why are we using for-in? We know that it has problems. But my main thing to emphasize here is that all of these are good unit testers. There's even more that probably a dozen more that I haven't mentioned, and it's really up to you to decide which one that you like. For me, because I do mobile devices, I prefer JS Test Driver because I can execute code on Safari, on the iPhone, on my Android phones, on my Windows Phone 7, and make sure that my unit tests are all passing on all of those devices, which is a little bit, more conciliatory to me. So let's take a quick look at what that actually looks like. As I've mentioned before, my IDE of choice, which is WebStorm, does support JS Test Driver built in, and that's another one of the reasons why I prefer my IDE. So if we go here, first thing I have to do is spin it up, and as I said, JS Test Driver needs a server, and normally you execute the server by opening up a terminal window, typing in some cryptic commands to kick off. It's a Java file, so you kick up the jar file, but here all I got to do is say, hey, do this, and that'll kick off the server. Now you'll notice that this line right here that's in blue, this is the address that I type in locally in order for whatever browser I want to run this stuff. And I can also do the same stuff, assuming that my phones are on the same network as my server, I can call that address, from a remote device as well. But in this case, we're just going to do it for Chrome. We're going to do it for Firefox. And you can see that it says JS Test Driver, and it's counting down some numbers, and this just keeps the port open while it's waiting for commands, as it says here that its server is waiting. Then all I have to do from there is say, this is the configuration file for JS Test Driver, and all it basically says is, hey, my source codes are here in a directory called source, my test files are called test, so let's go ahead and execute these tests. And you can see here's source, and in this case the only thing that I'm really testing is this method called string format time, or strf time, and then there's a tester for this guy. Oh, I keep forgetting I stuck that in there. That's part of a different demo. So in this case, we see that my tests are now green. It went through and executed. And to prove that there is no man behind the curtain whom you should ignore, let's break something. Because what's the point of writing unit tests if you can't break them? So let's see, where do I want to break something at? Oh, first off, I should be in the test, not in the code. I could have did it either way, I guess. Okay, so in this case, let's just change this 2009. What's going on here is this test, my setup routine for this test is setting the date to the year 2009, the 9th month, the 2nd day, the 22nd hour, the 14th second or minute, and the 45th second. And that's what it's setting it to. And then the teardown just deletes this date object. Hey, by the way, how many people here knew that there was the delete keyword in JavaScript? and it does exactly that. It deletes things. It's one of the ways that you can prevent memory leaks is by getting rid of objects when you don't need them. So this guy goes through, it sets it all up, and what we're going to do, so instead of this being 2009, we're going to change it to 2010. We're going to re-execute our test. I got to remember to get rid of that. And suddenly now my tests are red. And of course, if I go through and change him back to 2009, and this is, again, the reason why I like this IDE is because I can just keep rerunning these things fairly easy. Pretty much like the same way that you can in Visual Studio. And also, I should probably comment that in Visual Studio 2012, which I just barely installed, like last Thursday before I went away on holiday for a few days, actually has a lot more improvements to their JavaScript interpretation and niceties, and I'm told that it can do a lot more things, and hopefully sometime in the next few weeks I'll have more time to play around with it. But now my tests are green again, and so that's JS Test Driver. And as I said before, I believe it's really important that when you make changes to a team that you try to involve everybody in the team decision. So, because a lot of these different things, a lot of these unit tests are all sort of X-Unity type, that they have that same basic structure of you have a setup, it may be called something different, you have a teardown, you have individual unit tests which ideally are testing one bit of functionality, and that if they pass, you know, the green continues. If they fail, something goes red. All of them do that. Their exact nomenclature is slightly different. And like I said, a lot of the people where I work, they really like Jasmine. They like it because of the way that its expressions go, and that you sort of nest in your test as you go in deeper, and you give, you know, instead of it, you know, in JS Test Driver I had a test case. It'll have like a name. Let's test the functionality of the user comment box, and then in the side of that there'll be, you know, individual tests, and I'll have like better sounding names. And because I'm already bad at naming things, that's probably why I'm not as thrilled about Jasmine, because I'll be thinking, great, now it's turned into a writing project. But there's lots of them. I was asked a question last night, and so I put this slide in here. There is a way to get JS Test Driver to work with Visual Studio's 2010. This is a blog post by a guy who actually put it in there, and I think most people could probably reason through the way that you do it, because Visual Studio has a way to run external programs, and JS Test Driver, as I said before, it's just a jar file, and you can execute it, and it'll spit out some results to the console line, and you can put those into your Visual Studio thing. But this guy has done it. And by the way, all of my slides are available right here, so people that are furiously writing, here's something shorter to write down. If you write that down and you go to that URL, the slides are all available. Everything that I'm showing you tonight is actually online, and you can just download it, and it's a lot easier than writing. I'm sorry, I should have mentioned that earlier. So as I said already, you want to involve your team in unit test choice. 100% coverage is tough and not practical. In fact, I would say that if anybody hits over 90% coverage of their code in unit tests, they've probably spent way more time writing unit tests than they should have. And I also like to open these kinds of things up as much as possible to not just the engineers, but the QA, and pretty much anybody that actually shows any kind of an interest, and most people won't. And the reason is because you want people to take a look at stuff, because everybody hits this stuff with a different approach and a different angle. And I believe that there's a lot of value in getting a different viewpoint on, you know, if you cruise through a bunch of unit tests, somebody's going to point out something that you miss, and it may be glaringly obvious to them, but maybe it was or something that you didn't work on, or something that you worked on a couple of weeks ago, and you've kind of just forgotten that it existed, and you've been concentrating on newer code or whatever reason. But I like to keep these things kind of open and kind of on, you know, and above board, as I say to everybody. If you want to see my unit tests, please take a look at them. If you've got comments that are, you know, hopefully helpful comments, please let me know, and I'll definitely take a listen to what you say, because I know I'm going to miss some things. Our final section, and this is our actual final section, is going to be talking about debugging. And debugging on a mobile device is pretty challenging, and the main reason is because guess what? Not Apple, not Google, not Microsoft has any vested interest in making it easier for you to develop web applications. That's the honest to goodness truth. And the reason is because if you sell an app in the App Store, Apple makes 30%. If you sell an app in the Google Play Store, Google makes 30%. If you sell an app on the Windows Phone 7 market, Microsoft makes 30%. Guess how much they get when you create a mobile app? Nothing. So even though they're great and benevolent companies that have nothing but the best for humankind in their hearts, they have no vested interest in making it easier for you to develop for the web. And so there's a lot of things that they could have done to make things easier, and they haven't. Apple has probably done the better job, but the main reason why it's tough is because you don't have any sort of developer tools on this phone. And if the problem is on the phone, and we have seen issues occur just on specific phones, as I said, we had an absolute issue that took us 3 days of like 3 of us concentrating on it to find where it worked on a Verizon Galaxy S2 and not on an AT&T Galaxy S2. And it was one of those weird things that was really tough to find. But it didn't happen in Chrome, and it didn't happen on the desktop, and it didn't happen in the emulator, and it didn't happen anywhere else, just on the actual device. So we're going to talk about what's the problem, why is it so hard to debug on a device. We're going to talk about analogs. We're going to talk about Wiener, and I don't care what Patrick Mueller says, I'm still calling it Wiener, not winery, in Adobe Shadow. I'm going to talk about iWeb Inspector, and finally I'll end up with the Opera mobile emulator. And one of the things that I like about all of these 3 tools, or 4 tools that I've mentioned here at the end, is that they're all free. So every device has a different browser, none of them have any development tools. The number one thing that most engineers will do when they start trying to figure out what the issue is with something is they'll do an alert box. And the alert box should be avoided as much as possible. And the reason is because it freezes the browser. Not only does it freeze your tab, like if you're working in Chrome, for instance, it freezes your tab, it freezes all the tabs. So if you were in the middle of an operation, such as downloading a file, and that alert box, comes up before that, right at the same time the server's sending you things, you get the alert box pops up because you're testing something out or you're trying to debug something, that Ajax operation gets suspended at the point where that alert box comes up. And there's a possibility that the server on the other side might decide that you're not responding, so I'm going to close off. And it's kind of a hard freeze. I prefer, if you're going to do something like that, to do a console log out, and most of these do support, all the ones that I worry about, iPhone, Android, Windows Phone 7, all support a console log. It's just now the question is, how do you read the console log? But it doesn't freeze the browser. And to kind of emphasize how trippy, because this is one of those things that we don't normally think about too much, is what happens when the alert box comes up. Let's just take a quick look at this guy. Now, hold on, actually, I need to explain the code first. Okay, so we just have a very, very simple piece of code here. All it's going to do is print a console log out that says alert blocks. It's going to set a timer to go off in 5 seconds, and it's going to print a message that says, hi there, I'm blocking everything. That's the alert blocks. So what we would sort of intuitively think would probably happen is that this message is going to pop up, 5 seconds is going to go by, and then this guy's going to come up. And that's not what's going to happen. So if we set this guy up, we see the alert blocks message, we see this guy come up. Now let's just wait for 5 seconds. 1,000, or what is it, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, and when we release this guy, guess what? He's still waiting. That's because that alert block, when it came up, it stopped everything, including the counter from timing. Everything dies when you put that up, and that's the reason why I don't like to use it, is because it's a little bit too harsh of a way to debug. And it's a very painful way. It's much better to use console logs out because they don't block. They're just going to get printed out, and everything in the JavaScript. And in case you weren't aware, JavaScript is single-threaded even when it's doing AJAX operations and doing things that seem like they're happening at the same time. It's all happening just one at a time, just really quick. So my advice is always to avoid that, you know, doing the alert or any of its cousins where it's asking, what is it, the questions and stuff like that. Just avoid them. So console logs out are better than alert, but the sort of the gravy, the sweet spot for debugging is to be able to set breakpoints, to be able to actually stop the code, see what's going on, see what values are in variables, and unfortunately that doesn't exist on any of the phones. One of my favorite ways to do something close to it is to use analogs, and in biochemistry, an analog is a substance that's similar but not identical to another. And in browsers, there are certain browsers that are similar to mobile browsers, but they're not identical. I mean, most of us would instinctively think, okay, well, I know that the iPhone Safari is called Safari on both of them, and you would be absolutely right. Safari for the iPhone and Safari on the desktop are actually built from the same code base by apparently teams that talk to each other and they like each other. Android and Chrome. Now the Android browser, the browser that Google saw so little of, they didn't even give it a name. It's just called browser. It was not their best effort. It was, let's just get this to market really quickly. And they're trying to make up for it now by finally releasing Chrome for Android, but it's only taken them 3 years to release Chrome for Android, which tells you that things are not completely right in the house of Google. But unfortunately, that's only for Jelly Bean phones, which make up, what, 0.2% of the market or something like that. Everybody else is stuck with the browser with no name. And they're going to be stuck with it for some time. And even on Jelly Bean, the built-in browser that you will get, like if you're using a PhoneGap app or something like that, is still the browser with no name. It is not using Chrome's core. It's still using the nameless browser's core. So you're going to be stuck with all this stuff that's in there, but Chrome is still a good analog for Android. For Windows Phone 7, it's going to be IE, and if you can get your hands on it, it's IE 7, not 8, not 9. I know Microsoft says in some of their literature it's sort of like a mix between 7 and 8, but from all the stuff I can figure out, it's 7. And there's a lot of things it don't do. It's woefully lacking. For BlackBerry, it's going to either be Safari or Chrome, because most people may not be aware of it. BlackBerry's browser is based on WebKit, and so are both Chrome and Safari. So that's why you should use those as analogs. Now, it's important to realize that analogs are good for like setting things up, getting things running. Like for me, I use a plugin called Window Resizer, which allows me to get the same size window as a mobile device, but this is not the same as a mobile device. And the reason is because it can show things in the same size, but for instance, I can't rotate it like I can my phone. And orientation change is an event in jQuery mobile. I also can't swipe it with my finger like I can on a phone. I also can't shake it and do all these other things that are, touch-driven events. Also, the thing is that mouse-driven is very precise. That pointer, I can put that thing right on a pixel. You can't do that with your finger. And so a lot of times when people develop stuff, on the desktop, and then they put it on the phone, they're surprised by how hard it is to navigate and how hard it is to use, because, well, you were using a mouse before, and you can put a mouse right on a single pixel if you wanted to. You can't do that with your finger, because your fingers, they're like me, they're pretty fat, and they're kind of clumsy and awkward. So you got to take using analogs with a grain of salt. Oops, didn't mean to do that. And realize that, yeah, it's good for a lot of stuff, but it's not a panacea. It's not going to do everything just like a mobile browser will. And so you have to be, a little bit wary. Back. And so I always pass on this thing of, don't assume that if it works on the analog, it'll work on the device. Always test on the device. And I can't overemphasize that, because a lot of times people get really comfortable, and you can do a lot of quick development when you're using a desktop browser, whether it's IE or Safari or Chrome, and you can get really comfortable, and then you put it on the phone, and you go, oh crap, none of this works, and you'll get surprised. Now, Winery or Wiener, I actually had a fun conversation with Patrick Mueller at Phone Gap Day, because this thing, when it first came out, helped me a lot. We were having some issues with CSS and HTML, and especially I was having problems because I couldn't figure out where one of my divs went, because it looked fine in Chrome and it didn't work on the phone itself. But what this is it's what's called a web inspector, which is really, it's not quite the same as a debugger. It'll let you see the HTML and the CSS of your phone in your Chrome browser or your Safari browser on your desktop, but you cannot set a you cannot set a breakpoint on it. So you can see your console logs go by. You can see, inspect different elements. You can actually do jQuery calls and, find different selectors and stuff like that. But this is a JavaScript application that runs on your phone, and all it's doing is sending information back to the remote host, your desktop. It's pretty cool, it's pretty capable, but it does not hit the sweet spot of being a debugger. Adobe Shadow is a Chrome extension, which when I first I thought it was this guy, because it was very, very similar. Once again, it's a JavaScript thing that runs as an extension, and you run it on all your devices, and it's like Winery with a better UI. And when I first talked to Patrick Mueller, I was asking him, I said, I thought you'd stop development of Winery. He goes, yeah. He goes, a lot of people have asked me that since Adobe Shadow came out. They thought that I started working there. And he goes, no, they just saw what I did and did a version of their own. And so essentially it's the same thing, and once again it has that same lackingness of it's not a debugger. You can't set a breakpoint and then it's peer into it. There's only one available that runs, as far as what I'm concerned, is a mainstream browser that does debugging, and that's what's called the iWeb Inspector. And once again, all of these tools that I've mentioned here are all free. Adobe Shadow's free, Winery is free, iWeb Inspector is free. The only catch is with iWeb Inspector is it only runs on the iOS simulator, which is a curious thing. But what it is that Apple has started building in some hooks into Safari, and they've exposed some of those hooks on the iOS simulator, but not on the actual iPhone. So it won't run on the iPhone, but if you run your simulator, it'll get these hooks, and you can actually do, hit breakpoints on there. So if you're either doing a web app, a mobile web app, or phone gap app, you can hit breakpoints in iWeb Inspector. See what the values of variables are, modify those values, and do other stuff. Now I'm told that the next version, probably starting with, and if I actually would catch up with all the stuff I'm supposed to have read already, starting with iOS 5, that those hooks will actually be built into the iPhone itself, that Apple has felt some pity on us poor developers and built some hooks in the Safari so that you can do debugging on a mobile device. But we'll see if that actually pans out. The final thing, and I mention it only because it's cool, but it's one of those things, it's cool, and the but is that it's Opera. And I have nothing against Opera. It's a fine browser. It is just, it doesn't ship native on any device. And usability study after usability study that we've done, just simply monitoring the traffic that we get. And when you get, one of the great things about working at a place that has a very busy website is I get lots of analytic data that tells me things that, you know, help me judge where I want to spend my time and focus on development. And one of the things I find is Opera rarely hits our site, both as a desktop browser and almost never. I mean, it does occur, but it's less than 1% on a mobile device are we ever being hit with Opera. I think it's like 0.15%.
What about iPhone?
Huh?
What about iPhone?
Oh, iPhone's probably 60% of our traffic. It's actually more than Android.
Do you use Safari?
Yeah, they all use Safari. And the main reason is, even on Android, where you think that it's a little bit more of a tech-savvy crowd, most users don't give a crap which browser they use. So, you know, on Android you have, you know, depending on which device, you might have Chrome, but you definitely have Firefox, you definitely have Opera available as choices, and people rarely change. Because they figure, I've got a browser, and I've only got so much memory, why would I give up, you know, space for a browser that, you know, and I already have one that works. But when you have Opera Mobile running on your phone and Opera running on your desktop, you can do remote debugging from your phone to your desktop. And it only, to the best of my knowledge right now, it used to be available for Windows Mobile, and one of the things that Microsoft did that pissed off Opera was when they said that they were going to Windows Phone 7 and you're going to have to rewrite all your applications. Opera basically said, we're done. We didn't sell that, we didn't get that many people use your stuff anyways, and it's not worth us rewriting our entire code base. But it is available for Android, and I like for, you know, most of the developers on my team, we have Opera installed and we use it for a sanity check more than anything else, to make sure that we haven't written code that was WebKit dependent, that was, too dependent on either Safari or Chrome. And so it's a good kind of just sanity check. You run your code on there to see if you're really truly HTML5 compliant, you know, that you haven't just hit the sweet spots of Android and iPhone and you forgot about Windows Phone and Opera, just in case anybody uses them. But it does have a true remote debugger though, that's actually pretty good. So now we've reached the end part of this thing, and you know, to wrap this up, I mean, JavaScript is a tough language, but it's not oversold. You know, I recommend always that people use the best tools and use the best practices. And most importantly, I always say is that whether it's something that I said or something that you read in a book or something you saw in a video, you know, to be pragmatic and not dogmatic, meaning that, you know, you do the things that are best for you and your team, not the things that somebody else said and you're not really sure why you're following, because, you know, different people have different reasons why they believe things, and their reasons may not be the same as yours. It may not coalesce. So, you know, you got to just, that's why I always say, you know, try to make these things as a team decision. You know, which I believe that you should always be unit testing, but which unit test you use, that's up to you. And, you know, how high you should unit test, you know, that's also up to the team. You know, my team, we strive for 80%. I've seen people try 85%, people try 90%, but I'm thinking at that point you're spending too much time unit testing and not enough time developing. Either way, ladies and gentlemen, or lady and gentlemen, that's it for me, and that's my talk.